Hi guys, Nganga Roya here. So today I'm very excited for this video because we are going to create a machine learning predictor model. So in this video we are going to use the English Premier League data and a couple of parameters like shots and their previous performances, etc., to see if we can predict if a team will win or lose or draw a certain match. This video will use packages like requests, libraries like pandas and BeautifulSoup. This will really be helpful in trying to get the data from the internet. So we'll get the data from the internet, scrape it so that we have all the information that we need, the shooting data, the goal differences, etc. And then once we get this data, we're going to create a machine learning algorithm which uses a couple of parameters to try and predict a win or loss or a draw. And this will use Scikit-Learn, we'll use random forest classifiers to try and predict these results. Also, we'll try and use rolling averages to try and increase the accuracy and precision of our specific machine learning algorithm. It's a very fun video. I had a lot of fun making it. I tried and make it on a single sitting. Took a lot of time, but I think the information that is here will be very, very helpful. So see you in the video. Okay, hi guys. Let's begin. First, start by opening up a Jupyter Notebook file. I will be using Jupyter Notebook, so I'll just start by opening up a blank file. The first thing we want to do is import something called requests. This request is what we'll use to download a couple of pages from the URL. And after importing this, the next thing we want to do is create or just define a variable that will hold our URL that we'll use to scrape from. So we'll just call it standings underscore URL, which will be equal to this URL. This URL contains football data for the Premier League. Let's see how it looks. When you open up this FB or FB ref, this is how it looks like. You can see a lot of blank rows here, and they're blank because the 2022-2023 season has not yet started, and that's why it's blank. And we don't want to collect our scrape data that is blank. That's why we use the previous season. We'll script from the previous season and the 2021, 2022, and the 2020, 2021. So that's why our initial URL looks like that. Let's go back to our Jupyter Notebook file. After defining this URL, defining this variable that will hold our URL, we have to download the page using the get, which is available in the requests. So by doing this, we define a variable called data, and then we say requests dot get, and it will get from the variable that you've just created called the standings dot URL. And when you look at this now, you can see these are a string of HTML, which is very, very big. You can see it here. Very hard to understand this URL pattern, but this is what the data text has taken. This is what the text is. The next thing we want to do is now let's start getting the data itself. Let's go back to our URL, the page with the data. When you look at this data from a perspective, we can see what we want are these specific URLs. There are so many things here in this page, but we don't want everything here. We want this specific URL where once we get in, like for example Man City, once we get in, we can now come and find information about the club itself, the players. We can find information on you can see the Premier League, Champions League, but so you're interested in the Premier League, When you go down here, you can see scores and fixtures, and you can see game week 1, game week 2, game week 3, game week 4, game week 5, etc. Once we scrape it and specify that we want the Premier League, we'll just get the game weeks, and this is what we want. And this is a URL pattern. Let's just right click. You can just right click here and inspect. You can inspect. I want it to, let me just change the format here and take it down there. Put it down here. I think that looks better. Okay, let's just reduce this a little bit. Perfect. And we want to look at the elements. When you come here to select an element in the page to inspect it, once you click this and go to Man City here, you can see it's an A tag. It's an A tag that contains the specific URL. Once you click this A tag, you can see the specific URL here for Man City. And each team has this specific URL, and this is the most important thing because you can see it's an A tag with a href with the specific URL inside here. It's not an absolute URL because it does not have the http://fbref.com/that, but it's a URL pattern that we need. So we need to pass this URL for each team. We'll first start with one team, but we'll need to pass this URL, this HTML, so that it can be scraped using something called BeautifulSoup. Let's go back to our code. So what we need to do now is import the BeautifulSoup. If you have not installed it, make sure you install it so that it can work. Go just pip install or conda install BeautifulSoup 4, and then let's continue. So what you're going to do here is from BS4, which is BeautifulSoup 4, we're going to import BeautifulSoup. We're going to import BeautifulSoup. Funny name, but it is a very, very powerful and very, very good library. We're going to import this, and now we're going to initialize a BeautifulSoup variable. We'll just call it soup equals BeautifulSoup, and then this will take now the data dot texts. After doing this, let's go back to the URL that contains the data. When you look at this URL, you can see this is a table, and this is the table that we are interested in. So when we inspect, we come here and inspect this. Select this. You can see that this is a table here. Exactly, this one is a table, and you can see it has a class of stats underscore table. So the table has a class of stats underscore table, and that's the table that we need to get into so that we can find this specific URL. Let's go back to our code. Now what we want to do is, first of all, get that table itself. So let's just create a variable. Let's call it standings table. And let it be equal to soup. We'll use a function in soup here called select. And this will just select, we'll tell it to select a table. You'll just see what I mean in a second. It will select the table stats underscore table, that was what it was called, and then that. So when you look at this, it has we have defined a variable here that will take the table that we have just seen, which has the class stats underscore table. We run this, and then when you look at standings table here now, It's also a very big URL, very hard to understand, but it's a little bit smaller than this one. This one was way bigger, but now we have taken the URL for this specific table. So what we want to do now, we have gotten the table itself. Now we want to take the A tags which had the hrefs, which had the links themselves. You remember when you looked at Man City, we saw it was on an A tag which had a href, and then inside that href is where we found the link itself. So now we want to use something called find all to get all the A tags in the tables using that find all. So let's say links equals standings table dot find all, then it will find all the A tags. This select and find all are almost the same, but I use find all here because it just selects this specific tags themselves. Run this. Now what we want to do is get rid of links that don't contain squads, because there are a lot of links there, and you might find links that don't contain squads themselves. So what we want to do is now come to links here, and then we're going to say it is equal to. Now we can create a small logic here where we say L for L in links if now the squad is inside, which you can see there is usually as there was a slash squads that was present in every single one that contains squads, like Man City had the squads in them. It was English stroke squads stroke a number that indicated the season stroke Man City. We'll just see it right now. In L, links equals to L for L in links if the squad is in that L. Let's run this. And when we look at links now, sorry, okay, it's not working. I think I've done something wrong. Oh, sorry, you remember it was in the href. So what we have to do before we do this step here, we have first of all to get the href properties of each link. So we do that by, let's run this. We've already run this. Then say links equals to l.get. Then you're going to get the href properties from this href for L in links. Okay, we run this now, and when you look at this, we have found all the teams now. You can see this is the squad that we used so that we can get the teams, and these are 18 teams. We can look at them like that. We can see how many they are. I don't think the list does not have that. Okay, when we look at this, these are 18 teams, the ones that were aligned according to what we saw there. Hope we understood what we've done here. We have created a variable called links where the standings tables, and it found all the A tags, and then these links using the list comprehension. We have basically using the list comprehension, we have found all the href properties for L in links. Then these links we have also used in a list comprehension again to get the links that have squads. Then now we have the links themselves. But remember, these are not links that can work. So we have because they don't have a domain, so we have to add a domain to them. So we have to use a format string so that we can add the domain itself. So this will look like this. Let's call it team URL, and this team URLs will be equal to, if you're familiar with Python, you know what I'm doing here. So we want to add the HTTP That's what we want to add, and then the fbref.com, so that when this is added to this, it forms a link that can work. And then inside here we'll add that, and then we'll have write L. This L, which is not defined, will be for L in the links. So in all of these links, L being will be each, this is one L, another L, 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 then they will all be added here, and then that's how it will work. Okay, when we run that, and now we can, when we look at the team URL else, you can see they are now links that can be used. Let's proceed. Now let's work with the first team, which is Man City in this case. Let's just say the team URL equals to team URLs, equals to team URLs, and it will take the first element in that list. When we look at team URL, it's team URL itself, we can see it's a Man City link. Then let's just do the process that we have done before. Let's say data equals to, let's use the get method in requests, dot get, and then let's get data for the team URL. Take this, it's get, not ge, no problem. When we live code, there's some problems that we always run through. And then when we look at data.text here, you can see also the URL, which is something very big URL here, but no problem. Now that you have gotten this URL, we have to look at the URL itself and find out which is the data that we want. What's the data that we want in this URL? When you come back here, you can see, when let's open Man City, which is the one that we're working with right now. Let's just go down, and the thing that we're interested in here is this scores and fixtures. These scores and fixtures. Let's go back to our code. So now we want to grab the whole table inside the first team and look at the scores and fixtures. We'll grab this table using something called pandas, which is a very, very powerful library in Python that is very, very helpful in trying just to get data from the internet and to work with data in matrix form. When I say data in matrix form, I mean the data that is are in rows and columns, and as you can see, the scores and fixtures were in rows and columns, and that's what we will use. So the first thing we need to do is import pandas as PD. So we import it as PD so that in every pandas function that is inside the pandas itself, so you don't have to keep on writing pandas every time. We just write PD, and you'll see what I mean by that. So we import that, and now let's create a variable called matches. This matches, you use pandas and it will read HTML. This is the powerful thing about pandas, it can just read HTML and drag and just get tables from that. This will take this specific data.text, that will be its URL. After taking data.text, it will use something called match. So we'll use match here. We can also use the ID, because if you look at the ID for that specific scores and fixtures, it has a specific ID that you can use, but let's not just match using the name itself. So we'll match using the name that was written there. Let's go back and see how it was written. We can see it's scores and fixtures. I can just copy that. Let's go back to the code. We're back. So we can use the scores and stroke fixtures. Just paste this here, and that is what it will match with. Remember, it can match with the ID, but we'll just use that for now. Let's run this, give it some time to go to the URL. It has finished, and now when you look at matches, you can see the table that we had there. So it has successfully scraped it, and then when you look at just at matches like that, you can see now it has been formatted well, and it looks very, very nice, indicating how many rows it has, etc, etc. Now what we want to do next is get extra data. Remember, we have gotten these tables, and it's very, very important. They'll be used in the specific machine learning algorithm that we're going to create later, but this is how it looks. Now we are going to get information on shooting, and we're going to get penalties, etc, etc. Let's go back to our site itself. When you look at this site and go to the bottom here, you can see not the bottom, sorry, just beside this, go down here, you can see shooting data here. There's goalkeeping, passing, etc, etc, but you can see shooting data here. When we inspect this, let's just inspect this and see what the shooting itself is. Inspect, look at the element. The shooting itself, we can see it's an A tag up there, up here, sorry, up there you can see it's an A tag. Okay, you can see it's an A tag, and when we click it, we can see it's an A tag, but there's a link that is missing. Let's just go back to scores and fixtures here. Let's just click this first. When you go back to the scores and fixtures, and let's now see what shooting is here. As you can see, shooting, let's just click it. You can see shooting here is an A tag which has a href. It has a link in it. So we are going to do the same thing, and we're going to extract it using BeautifulSoup, because while we are still on the scores of fixtures, we can get the A tags, and with the href find all the links with shooting in it, and then we use BeautifulSoup to extract the data itself. Perfect. Let's go back to our code. First, we have to do the same thing we did up there. We'll initialize a soup instance. We'll call it let's just do this real quick, what we had done before. Then it will use data.text, and then after doing this, we'll just take links. Let's just say links equals soup dot find all. Remember, we used find all previously. Let me just write this real fast, and it will find all the A tags. Then we're going to use list comprehension here. Sorry, I've find all, sorry. Then we're going to use list comprehension here. So we're going to say links equals l dot get, and then this will get the href, and then for L in links. Okay, after this we have used the list comprehension again, and then to be equal to, we use list comprehension again for L in links if L, and now we'll change it to and. We need it to be a link, and we need it to also have all comps. If you look at the shooting, it has all comps under slash shooting. That it looks like that. Okay, in L it looks good, and let's just run this. So when you look at links now, sorry, I think I've missed something. Yeah, it is all comps. Okay, let's just take it from the top. Take it from the top. Good, good, good. Perfect. We can see there are 4 links, but they are the same, and I think we are good to go. Then we're going to minimize the process above, where we first of all requested the data from a specific variable that we created, and just go directly. So what we're going to do here, just follow with me, will be equal to requests dot get, and then we'll go directly to creating a formatted nini here, which will be, so I've said you're going to go directly here. Let's go real quick. So remember, we've formatted this and then we used HTTP fbref.com, and then inside here we're going to put now these links. Remember, we just need one, so you're going to put link here, links, and then going to take the first element there. I think everything is good. Run this, and when we look at data.text now, remember we're going to get that HTML string, very long HTML string, and then when we read this HTML using pandas, we're going to use, just let's call it shooting underscore stats. Let's say shooting underscore stats will be equal to pd dot read HTML, and then it will take data.text, that long HTML, and then it's going to match now shooting, match equals the shooting now. Okay, and let's just specify for it. Let's just take the first element in this, run this, and when you look at shooting stats now, you can see it's this shooting data where we have distance the shot has gone, the free kick, the penalties, the penalty kick attempts, expected goal, etc, etc, etc. Now we've gotten some more data that we can use on our machine learning algorithm. Now let's proceed to just cleaning and merging the script data from pandas. When you look at this table up here, you can see this from Man City, standard, expected, etc. Then there is this other one. This is called a multi-index. It's a multi-index, and it is important in some cases, but for us it's not important. So we'll just first start by dropping one index level, since the shooting data frame has the multi-index. So we'll do this by, let's just say shooting dot stats dot columns, then this will be columns will be equal to shooting the stats dot columns dot columns dot drop level. This will just drop one level. Perfect. And then now we look at shooting stats. Let's just take the head. You can see it has just one index level now. Okay, the next thing we want to do is see how we're going to merge the two data frames. Remember, we have removed the multi-index because if you want to look at something like date, let's say shooting data, let's look at something like date. Let's just take the head. You can see it is very easy to get this, but when it was a multi-index like this, it will be very hectic to get just something as simple as that. Well, multi-index is important in some cases. For us right now, it's not that important. Okay, now what we want to do, we have matches data, we have shooting data. Now what we want to do is merge these two data so that we have one long data frame that has all the data that we need. Because you can see matches.head, let's just check this out. .head. Oh, sorry. You can see we have this, and then we can also look at the shooting. Let's just prevent this from being too long. We can look at shooting here, and we have this. Now we need to merge these two data points, and to do that, so the way we are going to do this, we are going to merge them using pandas. Let me show you how we are going to do that. So let's just define a variable here. Let's call it team. Let's call it team data, and this will be equal to matches. Because I don't want to keep on repeating myself, so let me just write matches equals to matches 0. Perfect. Then we're going to now to merge them. Let's just define team data now. It will be equal to matches, and then matches will be merged. So dot merge to the shooting data, which is shooting stats, and then we're going to merge this on a couple of things. Let me show you how we're going to do that. So we're going to use date, then we're going to use the shots, and then we're going to use the shots on target, and then we're going to use the distance covered by each specific shot, which is dist, and then something else. We're going to take free kicks, and then we're going to take penalty kicks, and then we're going to take penalty kick attempts. I think that's good, and then we are going to do this, all of this on the date. So these are the data points that we are taking. And then you're going to merge them on the date. I think this is date. I think it's good. We run that, and now when you look at team data, let me just write .head so that we're not dealing with something too long. You can see it has added the shots on target, etc., and it has merged them on the date, so every team has it has merged perfectly. Okay, now for our machine learning algorithm to work, we need data from multiple seasons and multiple teams. So we have just worked on Man City now, but now we are going to get data from multiple seasons and multiple teams. First of all, just to define a variable, we'll call it years, and the years will be equal to just a list, and inside this we'll just have a range, and it will be 2022 to 2020, and then a -1 here, and I will see what this means in a second. When you look at years now, we can see it's 2022 and 2021. Then we want to initialize a list called all matches. Let's just call it all matches, which a couple of things will be appended inside this list. this will be equal to this. We've initialized the list here, and then we are going to use our initial URL. Remember our initial URL? I'll just copy and paste it here, and this was it. Okay, now let's move on to creating now this a loop. We're going to create a loop that is going to loop through all this data and help us just to create this specific of loop that will help us just to get every single data from every single team for the past 2 years. Okay, let's start. So let's just say for year in years. Okay, let me just create a couple more here so that it can move a little bit up. More step. I think that's good. So for year in years, so for 2021 and 2022, we're going to just do the whole process that was up there again, where we're going to take the data. I'll copy paste some of these things. Okay, so the first thing we want to do here is we get the data, initialize that data variable, and it will use the get in request to get the HTML data. The next thing we want to do is initialize that soup instance. Okay, where we just script the data for that specific URL that was found on that standings.url. Then we are going to get the standings table. Remember, these are things that we have done up there. You can find them. After doing this, then we just remember what we did here. We've used find all to get the links, the hrefs in the standings table. Then we are going to get the squads links so that we have the links that contain the squads. Then we are going to just format the string so that the links have the domain name fbref.com. What we want to do next is, because we want to work with data also for the previous season, we'll define a variable here, previous season. Let's call it that, and that will be equal to, let's go back to the data that we had, the data on the, so I just received a call there. Let's go back to our URL. When we look at this, we can see there's a previous season here, and when we inspect this previous season, we can just see, this previous season, okay, when you look at this here, you can see the previous season is an A tag with a href that just reflects to the 2020, now 2020, 2021 season. This is the previous season. So what we want to do, let's go back to our code. Okay, now our previous season here will be, you remember that was an A tag with .prev. Let's just look at it again. You can see it's an A tag, and then when you come here, you can see, let's just click this. You can see up there .button, div.button2.prev. So it's an A tag .prev, and let's just go back to the code itself. So when defining it, we can just say, let's script that. Let's say soup.select, and what we want to select now is an a.prev, and then it will take the first instance, and then it's going to get, what it's going to get here is the href. As you saw, it's a href that reflects the previous season, like that. Okay. And then now our standings URL, this one up here, will change to underscore URL. This now will change to a formatted instance, which will have to be a formatted instance, which will just take, remember, the HTTP, this two backslashes, then fbref.com, and then it will take the previous season. Okay, so what I've done here, created an instance called this previous season, that variable, which the soup will take the a.prev as we've seen, will take the first instance, get the href there, and then it will attach that href to this, because that to make it an absolute link, which has this domain name, so that will be the next instance. It will take the data that we have, then it will go to the previous season and take that too. Okay, let's continue. Since the URLs are many, we'll have to create another for loop inside here. So which will take the you remember the team URLs were all those 18 URLs, so it will be team URL underscore URL in team URLs, it's team URLs. And what we want to do here is, first of all, remember how we want to get the name. What we want to do now is get the team name. Remember, when you look at the team name, it will have all those dashes and slashes, etc., etc. And for you to understand, let's just look at team name, team URL, team underscore URLs. You can see this, how it looks, and we want this name only. So for us to get that name, we'll have to let's say team URLs, then we're going to split this, and we're going to split it using the slash itself. So we'll split it using the slash like that. And after splitting it using the slash, we're going to take anything after. Understand? So you're going to use -1 here. When you look at this, sorry, I think I've made a mistake. Okay, oh, it's a very big list. Sorry, let's just take the first instance here. I think it will work now. As you can see, when I split it like that, we get Manchester City underscore Manchester-City-stats. After getting this, now we need to get rid of this stats. Okay, so we're going to replace. We're going to use .replace. By using this .replace, we're going to replace the first parameter it takes is what we want to replace, and what we want to replace is -stats. And then the next parameter is what we want to replace it with. We want to replace it with blank. When we do this again, you can see Manchester City. It looks good. Something else that I want to change is because I don't want to use this dash here, I'll just replace that also with space. So we'll just take the dash, and then replace it with a space, and then we get a Man City there. So this is the code that we are going to use. Copy. But now, because we have separated them, we don't need that. Because we have separated them, we don't need this. So it's going to be team URL like that. Perfect. Then we are going to do just the same thing that we did up here. Take the data, which will be equal to request. I think I will just copy paste this rather than writing them all down. Okay, let me just paste this. Okay, so it takes the data and collects from the team URL, that specific URL, which is going to iterate through all the URLs. Then now we are going to define, remember what we did, took matches, then we read that score and fixtures. The next thing we want to do is initialize that soup from that data.text HTML string, and now we get the data itself. Then we are going to use, remember what we used, this to get the A tags, then use that to get all the shooting stats, then use that to make sure it's a formatted string that makes combines the domain name with the extension of the URL. Then we are going to use pandas to read the data.text so that it arranges them in a matrix format as it is in the page itself. Then we're going to drop a level, remember it was multi-level, and then after that we have taken everything that we need from there. Then remember what we did next. We used merge. Remember, we merged all this data by using something called try. We merged all this, and now we're going to use something called try, and I'll explain to you in a moment. So we're going to use try here, and let's just say try team data underscore data equal to matches, then dot merge. Remember what we did up there. I'm doing this as fast as I can. Shooting. Okay, then this will be date. Remember all that we used up there. Okay, I'll just paste it here. We use date, shoot, shots on target, the distance covered by the shots, the free kick, the penalty kicks and attempts. Then we merge them with the date, using the date as the play what will merge on. I think this is not supposed to be here. I think that's good. Let me just check this shooting data. Okay, the brackets are fine, everything is fine, comma, perfect. But remember, there's some instances where the shots are 0, where the shots and targets are 0, and the data is not complete. So it might bring an error of value error, no information or something like that. So use try to make sure that we can create an exception where we can say except value error, except value error, continue. Okay, so what this does, it just tries and merge all this, and if there is an error, it will just continue. It will not keep on throwing errors at us, so that it just combines all the data. Even if there are blank cases, no problem, just make sure it combines all of them. What you want to do next, remember we're dealing with data that is the data that we're dealing with has all sorts of things. When we go up here, you can see there's the Community Shield, there's the Premier League, there's the UEFA, the FA, etc. So what we want to do is this comp column, we want to make sure that the team data, this specific column, the team comp, so team data, these competitions themselves, want them to be equal to Premier League. Okay, sorry, I've made a mistake, no problem. It's supposed to be inside here. So this team comp is supposed to be equal to Premier League. We don't want anything else that is not Premier League. Premier League. Yeah, so we just want the Premier League. Okay, and now this is what we want our team data to be. we want it to be equal to that. Then we'll add a couple of things here, which will be team. We'll add a column which will be seasons, or season per se, equals to the year. So if it's 2021 or 2022, and then something else. Let me just create a space here. Team date. The team name now. Remember the team name that we have just made using this formula here. So that we'll just create team underscore data. That now will create a new column which we'll call the team, and this will be equal to the team name. Okay, I think I've made everything fine. Team name. Okay, I think everything is fine. Something else, remember, we had this all matches that we initialized up there. So we have to append now to this list. We have to append now the data that we have created, the team data. Okay, everything looks fine now. And because we're scraping this data now in large volumes, the websites allow you to scrape data, but they don't like their data being scraped over a very long period of time, or because it will make the servers a little bit stagnant. So what they do, once you're scraping too much data, they either block you or you get incomplete data. So what we want to do, we want to create a sleep where once it collects one, it waits maybe a second or two, collects again, waits a second or two. It will take some time, but will collect everything that we need. So what you want to do here is use something called sleep. There's a called sleep. There's a library called sleep, which I have to import. That's sleep is in the time library. So we just import time here. After importing time, now we can do something called sleep. So we'll just do time dot sleep, and then we'll tell it to sleep for maybe 4 seconds. Let's put 3. It will take some time to run all this code, but once it has run, it will collect all the data that we need. Let me just get rid of this, delete that, and then let's run this. Okay, after it finishes the scraping, which might take a little bit of time, what now we want to do is use something called concat in pandas. This concat helps us just concat objects on a specific axis, and let me just show you what I mean. Let's just create the match data frame, and we'll use pd.concat, and then we'll concat all matches. Okay, let's proceed. After this, we want to create a CSV file from this data. So when we say match df, then we're going to use something in pandas called toCSV. This toCSV will just create a file, which let's just call it matches.csv. So we'll just create this file and save it. And before we do that, I've done it by mistake, no problem. Just write matches1 here. Before we do this, I want to, because I keep on changing, you can see comps, there's a capital letter, there's a couple of S or T, like shots on target is S, capital S, small o, then capital T. I want all of them just to be small caps. So let's just say match sorry, underscore df, I think it's here. Let's just say the columns themselves, we want them to be equal to lowercase, lower for c in matchdf.columns. So what this does, it takes this, converts everything into lowercase, and then puts them in each of the columns. Then let's just do this. Okay, so it looks good. Then what we want to do is we can check the shape. The shape will help us understand if you have all the data points that we need. So we'll just do match df here very fast, dot shape, run this, and you can see 520 by 27. And remember, if you know something about the Premier League, they play 38 matches, and these 38 matches are played by 20 teams, so multiplied by 20 teams, and we have 2 seasons, and this is 520, so we know we have all the data. Some of you might not have all the data. Make sure when you're running this, give it some time. It might take quite a long time, but make sure you give it enough time so that you can get all these data points. Okay, we can check a couple of things, but I don't think they are important. But let's just check something like of all these teams. Team. Let's just check the value count. Value underscore counts. Okay, value counts, run this. I think I've maybe made a mistake, but let's just wait and see. Okay, you can see 76 matches, 7 perfect. You can see all these have 38 matches. No problem there, because as you know, 3 teams in the Premier League are relegated after every year. So these teams were relegation teams, as you can see. Sheffield, Aston Villa, Norwich, Cardiff, Fulham, and Huddersfield are teams that usually get relegated. Okay, let's move on to the next step. Now we've seen we have all the data that we need, all the teams that we need, and let's now move on to the next step. Okay, now if we look at something like matchdf dot types, matchdf.dtypes. When you look at this, you can see the type of objects they are, and this date, you can see it is an object column. What we want it to be, we want it to be a datetime column, so we have to convert it into a datetime column. And how to do that, just create a couple of more here, down here, so that it's more centered. So what we want to do here is take this match.df, and then on this we want to take the date. What we want to do this date is like because when we do this, it's like we're creating a new column, but since the column is there, it will change what the column contents are. So we use pd.to underscore date time, and this will take the matchdf, and it will take the date. So what's happening here, we're taking this date, which is as we can see, the type is object here, and then we're using pandas to date time and converting it to date time and then replacing it here. And when you run this, you can see how it looks by just going to matches.dtypes, and now you can see the date is it's date time, its type is date time, the other ones are objects. And we need this because we'll be dealing with time a lot, because we'll be dealing with time and date, and we want it to be date time type of variable, so that it can help us use this type of data. Let us continue. Let's proceed now to creating a simple machine learning algorithm. Okay, let's proceed to making a simple machine learning algorithm. And we need to encode a couple of things here, because for us to create any predictions, we don't need any data that is in string form. So we need to encode things like the venue, the teams, home and away, to give them numerical values, though categorical, but they should have numerical values. The first thing we need to do, let's just look at match df.head, and you can see this day of the week, venue, results, all these are in like string format, and we want to make sure we have something that is we can create a machine learning algorithm with. So we have to convert them into categories, and how we do that is just we're going to go match df, then we're going to create a new column here. We'll call it venue code, and this venue code will have sorry, let me just do this to make it look a little bit better. This venue code will take the match venue. It will take the venue, and this venue it will use make it as type, and then it will use make it use category, and then it will convert it into categories, distinct categories, and then we can use this .cat.codes to make them have specific codes like 0 and 1. So when we run this, and now we check on match df, let's go back here and just run this again. You can see the venue now, there's 1 0 1 0 1. So the venue, either home is 1, away is 0. Home is 1, away is 0, home is 1. Okay, let's move on to creating codes for something else. As I've said, since machine learning does not operate with string values, we have to convert them into categorical values with the numerical encoding. So we do the same to the opponent. So let's just create match underscore df, and then we'll create a new variable here. We'll call it opponent code, and then this will just do the same thing here, and use the opponent .cat.codes, run that. Maybe I've written something wrong here. Match df match I've forgotten as type here, as type. Some of this live coding you make a couple of mistakes, but no problem, as long as you know what you're trying to do. As type category. Okay, and then when we go back here, run this, you can see their opponents. There's 16, which is Norwich. Arsenal is 0, Burnley is 4, etc. Arsenal is always 0 because they don't know what they're doing in the Premier League. Okay, let's continue. Something else that we need to see is there is this time here, there's the date, and we want to extract the hours now. To extract the hours from this, so that maybe there's a team that performs better at a certain hour than the other. So we're going to create another one. We'll call it match df here, and we'll call it hour, and on this hour we'll just have the match df, and it will take the time. It will take time, and what we want to do now is use the replace. Remember when we used replace there to get the team name, now we use replace here too. So dot replace, and what this replace now will do, will take everything that is after that and plus. So what this says is everything that is after this comma, semicolon, and after, remove it and replace it with something with blank. So when you remove everything that is after this and after, you'll remain with 12. And then we just say something like this regex equals true. Don't mind about that. Then you're going to say as type, we want it to be an integer. This time we want it to be an integer. So because, as I've said, machine learning algorithms uses numbers. Okay, run that, go back here, check this out, and you can see you have hours 20, 15, 17 according to this 12, etc, etc. Okay, let's move on. Now we're going to encode the day of the week. So we're going to create a code for the day of the week, which will just be the same thing. Let me write it real fast here, and then we're going to call it day code, and this day code will be equal to match df, and then it will take the date. So what you're going to do here, rather than using this Friday, Saturday, Sunday, days that are here, which will use alphabetical order and then encode them. So because we want it to be 0 being Sunday, 1 being Monday, rather than it being alphabetical, we want it to be on a daily basis. We're not going to use these days and set as category, because Friday and Saturday we want them to be next to each other, which is 5 and 6, rather than having Friday being ahead of Saturday, because Saturday and Friday are very different on the alphabetical table. So what you're going to do, the type we're going to use here is we're going to use date, and date we're going just to take something. We're going to do this. Let me just write it, day of week. So what this is going to do is going to put them in Sunday to Saturday, then give Sunday 0, Monday 1, etc. That's a better way of encoding the days themselves. And as you can see, when I do this, you can see there's a day code here, and you can see Friday is 4, Saturday is 5, and if we had Sunday, I think I can maybe say 10 here, run this, you can see Sunday is 6. You can see the days are running from 0 to 6, that's why it's ending at 6, because the first day of the week, which is Monday, is 0. So it's 0, 1, 2, 3, 4, 5, 6, rather than 1, 2, 3, 4, 5, 6, 7. Let me return this like that. Okay, so I've created a couple of encodings here. Now we should think about starting to train our machine learning algorithm. We have to think about how we're going to train this specific machine learning algorithm that you're creating. So first of all, what you need to do is need to determine the variable you're trying to predict. The variable that you're trying to predict. And here we want to predict if a team wins or not. If a team wins or not. Let me create a couple of those. So our variable that we're trying to predict is win. So our target variable is win. Okay? Our target variable is winning. And remember, as I've said, you cannot use strings. So you cannot use W, L, or draw. As you can see up here, it's either a win, a W, or a draw, or an L. And because we want to predict win, we want win to be 1, then draw and loss to be 0. If you want to create a more complicated machine learning algorithm, you can say where loss is 0, draw is 1, win is 2. But now I just want to create win or draw is 0, then a loss, win or draw or loss is 0, then a win is a 1, because that's the variable I'm trying to predict, and I'm just going to split them into 2 rather than splitting them into 3. So how you do that is let's just create a variable here. We're going to call it matchDF. So we're going to call it target. So we're going to create a new column here. We'll call it target, and this target will have win as 1 and draw and loss as 0s. So okay, let me just write it real fast here. matchDF will be now the result. Remember, this is result here, so it will take the result, and if the result, it will take the result, and if the result is a win, the result equal win. It will convert it as type and make it an integer. Okay, that looks fine. Match the target. Okay, everything looks fine. Let's run this. I think I've made a mistake. This is supposed to be inside a bracket like that. Perfect. So when we come and run this again, you can see the target here. Because all these are wins, let's just add here, make it 10. So win. When there's a draw, it's 0. Let's make it 20 here. We want to see what I was meaning. Man City is a very winning team, so that's a very big problem here. Let's just have it all and look at the bottom team. Yes, this is better. You can see everything that is a loss, it's 0, 0, 0, 0, 0 here, and if it's a win, it's a 1, because you've just split them into 2. Just use .head here again. Perfect. Now we have split the data, not split as in train split, but now we have known our variable that we're trying to predict. We're trying to predict a win. Okay, let's move on. So what we want to do now is pick a random forest classifier. We're going to use from Scikit-Learn, we're going to use something called random forest classifier. And the reason why we are not using a linear type of predictor variable or predictor algorithm, we're going to use a random forest classifier, is because this random forest classifiers usually picks up things that are not linear, non-linearity in the data. For example, if you come and check on something like opponent code here, you can see Arsenal is 0, Norwich is 16, so Southampton is 18. There's no specific linearity in that. Arsenal being 0 and Southampton being 18, it means that Arsenal is better than Southampton, or Burnley is better than is better than Newcastle because it's 4 and Newcastle is 15. There's no specific linearity in the data. That's why we are using a random forest classifier. Okay, for us to do that, we have to start by first of all importing that. So we're going from the Scikit-Learn .ensemble. We're going to import the random forest classifier. Okay, Scikit-Learn random forest classifier. Perfect. Now what we want to do is initialize the class by passing some parameters, which will take n estimators, number of the decision trees we want to train, and then we're going to take the mean sample split, and then we're going to put a random state to it. Let me just write it down so that you understand what I mean. So we're going to take rf, and then it's going to be initialize that class, and then random forest classifier. And what this usually takes, when you press shift tab, you can see n estimators. If you don't write anything, it will give you this n estimators, all this. You can see the random state is none. You can see the mean sample split is 2, etc, etc. So but we want to put and have our own, so we'll start close this by providing the n estimators, and let's just use 50. The n estimators basically is the number of decision trees we want to train. It's the number of decision trees we want to train, and the higher the n estimators, the more times the more accurate it is, but the more time it will take to finish up the training. So we take 50 there, and then we're going to use something called the mean sample split. So the mean sample split is the number of samples we want to have in a leaf of the decision tree before we split the nodes. So basically the number of samples we want to have in a leaf of the decision tree before we split the node. And the higher we have, the higher this number is, the less likely we are to overfit, but the lower the accuracy. So there's overfitting that might happen if the number is too low, but the higher the number, we are less likely to overfit, but the accuracy kind of reduces. So let's make it 10 here, and then just have a random state of 1. The random state is how many different results we get from when we run, because and I want, if I run it, I just want to get one result. But if I rerun it, I'll always get that specific result, because I don't want to keep on getting new results. Okay, we run that. The next thing we want to do is split the training and test data. Since this is a time series data, the training data and the test data should have difference in time. What do I mean? How the machine learning algorithm works, it takes data, and this data that it has, once you split it, you'll split it into train set and a test set. The train set will be used to train your algorithm, and then the test set will be used to test it. So we want to train it with past data, then try to predict future data. Okay, we want to train it with past data and try to predict future data. We don't want to train it with future data then predict the past, which you already know. So we'll how we'll split this, let me just write this real fast. The train data will be, let me write this real quick, will be the match data of the date that is before 2022. So anything before 2022 will be let me just show you 2022-01-01. So anything before 2022 will be our training data, and then our test data will be anything that is after 2022. So everything that is after 2022 is what we are trying to predict. Okay, run this. Okay, then remember we created all these new data points, which are the venue code, and we had the hour, we had the opponent code, we had the day code, etc. These new data points that we created, this will be our predictors. So our predictors will basically be these new data points that we created. Predictors will be equal to the new data points that we created, which were venue code, remember there was what else was there, opponent code, okay, we had hour, and finally we had day code. This will be our predictors. Okay, create some space down here. This will be our predictors. So now we can fit our random forest model so that we can see how it is. Okay, let's proceed now to fit our random forest model. We use the predictors so that we can predict the target. Remember, the target is to see if something is a win or not a win. So rf.fit okay, then it's going to take train predictors, train. Perfect. So it takes in the predictors and tries to predict the target. Okay, run this, and it has initialized that, and let's generate predictions in the tests predictors. Okay, let's generate predictions now. Okay, what now we want to do is let's say just say preds equals to it will take this rf. Once it takes this rf dot predict, and now this will use the tests predictors, sorry. So it takes it basically generates a prediction for these test predictors. Okay, perfect. I think maybe there's something wrong here. Just look at it. Okay, sorry for that. I had to restart my kernel and redo the code again because there was a problem with my machine, but we had gotten here. So what we want to do is generate the predictions for the test predictors, and let's just run this, and now we have that. The next thing we want to do is determine the accuracy of the model. We have fitted that, and we want to determine the accuracy of the model. The accuracy, we're going to use something called accuracy score. We're going to use a couple of metrics, but let's start with the accuracy score, which is basically checks all the time that you're correct. When you predicted a win, if it was correct, and when you predicted a loss or draw as 0, if it was correct, then combines this accuracy. So from Scikit-Learn dot metrics, what we want to take from this is something called the accuracy score. Import the accuracy score. Then what we're going to do now, let's just check on the accuracy. So accuracy score of the tests now on the target. Tag on the target, and we add preds there. Run this, and you can see our accuracy is 60%. So we are 60% correct on our wins. When we say it's a win, we're 60% correct when we say it's a win or it's a loss, and it's actually that. But remember, the thing that we're concentrating on this specific one is the wins. So we want to check on the wins. Okay, before we do that, let's just check on how many of our predictions about the wins or about the losses or draws were correct. So first of all, we're going to combine this data. We're going to create a variable called combined, and this variable called combined will convert this into a data frame, which we use the pandas library. Let me just do that real quick. And this data frame will use the dict. So I use a dict, and then we'll take the actual tests. So the actual will be the tests. Actual will be equal to the tests of the target now. Sorry. Okay, and the prediction will be the preds. So comma prediction. So the prediction will be equal to the preds. Okay, I think that looks good. So we are just creating a data frame with actual and prediction as the columns basically, and then the tests and the preds as the target, so that we can see how this one looks. Sorry, the dict, it's not dict, it's a small dict. Okay, and then now what we want to do is create a cross tab. This cross tab, let me just write it real quick. This cross tab will help us understand this a little bit more. So what it will take, the index will be the actuals, actuals, and then the columns will be the predictions. So the combined, okay, prediction. Okay, I think that's good. Run this. When we run this, we can see that we were correct 186 times when we were saying either a team will lose or draw, and wrong 106 times. Okay, so when you do that, 186 divided by 1 divided by 186 plus 106. When we run this, we can see we were 63% correct when we were predicting wins or losses, draws or losses. And on the other hand, by just looking at this, we can see it's about 50%, which you can just do 49 divided by 49 plus 47. And we were 51% correct on that. Let's just get rid of this, because we were interested on having predicting the ones correctly. We'll not use this metric to measure our error per se. We'll use this metric, not use this metric to measure the error. We'll use something called precision. Since we are more concerned about predicting the wins, we use precision, and precision will be our best will be the best thing to rate our algorithm with. The precision will only check the accuracy of the parameter we are trying to predict. So let's just go from Scikit-Learn, sklearn dot metric, import the precision score. So this precision score will help us create the precision and look at how precise our algorithm is while checking for wins. And remember, we just did it up there, 49 divided by 49 plus 47, which was about 51%, but let's just finish it up. So you can just check on precision, precision score, precision score. Why is it not coming through? I've not run this, sorry. I have to run this first. Precision score. And then this precision score, we want to check the same thing we did up here. We want to check on the test target and preds. So we just do tests, and then we'll check on target, preds, and we'll find that 51%. Okay. We are 51% correct in predicting this. So what we can do is we can try and improve this precision. We can try and improve this precision by trying to add a couple of variables to this. So you can improve this precision by using something called rolling averages. Let's see how we're going to do that. So we need to create more predictors to improve our accuracy by splitting the match this specific data frame by teams so that we compute the rolling averages. So first of all, we need to group this data. Let's create these grouped matches. Then this grouped, let me just call it grouped matches. These grouped matches will be the matches data frame that we have grouped by team. Okay, so we're going to create moving averages for each specific team, taking the like 3 or 4 previous games. For example, if a team wins the next match, they probably will win. And if the previous 3 matches were draw, lose, draw, they probably win or lose or draw. So this is what we'll use as the moving averages to help and just try and improve this specific algorithm to make it a little bit better. Let's just run it very fast so that this video does not become too long. We will group this by team, group by, and then we'll group by the team. Okay, after doing this, we need to the next thing we need to do Let's take an example of Man City. So let's create a let's say group equals to group. What's going on? Let's say it's this, and we'll take Man City. Manchester City will be our guinea pig on this example. So Manchester City. Okay, then let's just sort these values using the date. Let's sort these values using the date. Okay. Okay, I've made a mistake. Manchester City. Oh, it's Manchester City. Okay. Okay, data frame group by is not callable. Oh, there's something that is missing here. It's supposed to be .get group. So this .get group will help us get that. And then when you look at group, run this, just take the head. This you can see it's Man City, and this has been grouped by the dates. Okay, perfect. So what we want to do is create moving averages, where we take these 3 game weeks, maybe say 2, 3, and 4, create an average, moving average for this that will be used on this specific game week. Or if it's 6, it will use 5, 4, and 3. If it's 7, it will use 6, 5, and 4, etc. Let's do it so that you can understand. Let's first of all create a function. Let me create some space here. We'll first of all define a function. This function, let's call it rolling averages. Rolling averages. Okay, this function will take a couple of things. We'll take the group, so the specific, if it's a certain team, then it will take calls and new calls. I will explain this as we continue. So this okay, this will just take this group as we had up there, will just be group, which will be equal to group.sort value. So then we'll sort it by date. Okay, we'll sort it by date. Then we want to look at the last 3 matches, so we sort them by date. This is the reason why we are sorting them by date, so that the last 3 matches are consecutive. The next thing we want to do is now create this variable called rolling stats. This rolling stats will be equal to the group, and then it will take the calls, the columns that we are going to define, and then it will use this function, this specific function where it will use rolling. Then it will take the last 3 games, and closed will be let's say closed will be equal to left. The reason we're saying closed will be equal to left, let me tell you, is because we don't want match 2, 3, and 4 to define match 4. We want 2, 3, and 4 to define 5. 2, 3, and 4 to define 5. If you don't put closed equals to left, it will do 2, 3, and 4 to define match week 4, and that will be using itself to define itself, which will not be good. So we put closed equals to left. Then we take the mean, which is because we are doing rolling averages. I'll just change this to stats. Okay. The next thing we want to do is create this other one, this other part of it, and call it new calls. So these new calls will take now the rolling stats. Okay, what we want to do next now is to drop the missing values. Okay, what we want to do next is now drop the missing values, because if the values are missing, we don't want it to have an to throw us an error. So we'll just do group be equal to group dot drop NA, and what we finish up with subset, the subset will be the new calls. Okay, it looks good, the new calls. And what you want to do now is to return group. Just write that like I've written it, and now we've created the rolling averages. Okay, sorry, this cannot have a space here. Okay, return group. Perfect, and it's good. Now when you look at calls, okay, sorry. Now we have to create calls. Remember, we have created this function that uses calls and new calls, and now we want to create what these calls are. These columns that we are going to use are going to be now the goals against, goal defense, shots on target, distance that shots are covered, etc. So this will be goals for. We'll take goals for. It will take goals against. Okay, it will also take shots. It will take shots on target. Remember, we changed this to lowercase so that there's no problem with just writing everything in small case. We'll take the distance the shot has covered. It will take free kick. It will take free kick. Sorry. It will take free kick. It will take let's write free kick here. It will take penalty kick, and it will take penalty kick attempts. PKATT. Perfect. So it will taking goals for, goals against, shots on target, distance the shot has covered, free kicks, penalty kicks, and penalty kick attempts. Okay. Then the new calls, which will be used to carry the rolling averages. We'll just format this to make it look like this. It will take the C, which we will just define right now. We'll take C, then on C it will add underscore rolling, so it will just be like goals for rolling. Then this will be for C in now the above calls. So when you check on new calls here, you see it's just this with the rolling after, to know that they are the rolling averages. Okay, let's continue. So let's look at this specific one for the first team. So we'll just remember this function we created up there, which will take now group, and then it will take calls and new calls. Okay, perfect. Run this, and now you can see there are the moving averages that have been created here. 2, okay, 1, 1, 1, 1, etc. Perfect. Now we want to make sure this runs for each one and everyone. Make sure it runs for every one of them. Let's just create spacing here and move this a little bit up. Okay, so what we want to do now is let's just create matches underscore rolling. So this will be the data frame with the rolling averages added. So it will be this match df. Then this match df will all be grouped by. Remember, we used group by. What's going on? Group by. And this group by will use the team, remember? And then this team, we now have to use the lambda function. So we'll use apply. And on this apply, we'll use the lambda function, lambda. And this lambda will take this x, which is the each and every team. And then this each and every team, it will apply the rolling average function, with x being the first parameter, then calls, and new calls. Okay, run this. When we look at matches now and run this, you can see how it looks, but remember it has a multiple index, multi-index. It is multi-indexed, so we have to drop that first index real quick. So create some space here. Okay, let's now what we want to do is, let's say match rolling, then this will be equal to match rolling dot drop level, and this drop level will drop the team. And then now if you check match rolling, sorry, return this to code. Just a moment, return this to code. And then when you check on match rolling now, match is rolling, run this, you can see we have dropped that first one. And when you look at this index here, it is kind of funny because there is like 6 as a couple of them. There are 1000 rows, but the last one is 40, so it means it's repeating itself. Now what we want to do there is create an index with unique values. So what you're going to do, match is rolling, the index itself, index, that index we want it to be equal to a range that is equal to the match rolling shape. Yes, I think that's good, and it starts at 0. And let's run this, and when we go back here, run this, you can see it's now 0 up to 1047 because it starts with 0. This one that is not there. Perfect. So let us continue. What we want to do now is, now we need to retrain the model so that it can use these rolling averages that you have just taken. Okay, what we want to do is now let's define another function, which will be the, let's call it make predictions. Make prediction. So this function will take in data and it will take predictors. Okay, then it will just do the same thing. It will define the train and the tests. After defining the train and the tests, we'll fit the train data and then create that array of the tests predictions. Then we're going to combine this into a data frame, and we're going to check on the precision, and let's see how this one looks. So the train will be the one that we used before. So the train will be that anything that is before 2022, and the test will be everything that is after 2022. Then remember we fitted this train, predictors, and the tests, and then defined the array preds, which will be these predictions of the test data, and then we combine this to a pandas data frame, and now the precision which we used, ignoring the accuracy score, now use the precision. And then what we want to do now at the end, we want to return combined, and we want to return precision. Okay, let's run this. Good. So let's say something else here, combined. Sorry for that. Combined comma precision, not score. Let's just make this equal to the function itself, make prediction. But this function, which takes in data and predictors, it will take in the data, which will be matches rolling, and the predictors will be the predictors themselves that we had up there, but plus the rolling averages. New calls. Okay, run this. We need space, some space. Okay, now let's check on the precision. Let's see if it has improved. Okay, the precision has moved from 0.5 to 0.6, which I think is a very significant jump. Okay, so we have seen the moving averages, how they have changed everything, and we can come up here and we can just remove this random state so that I can demonstrate something. When we run this again, it will produce a different random state where accuracy is 0.6, our precision score is 0.53. We run this to the bottom here. Okay, let's define that precision, and you can see it's still increasing. Okay, it really helps because we have seen reaching the rolling averages, it increases the number of times when we say wins will be wins, and that is a very important thing to help you in just after retraining the model. Using these rolling averages, you can see that the precision increases. Let me just return this to what it was, random state 1. It's here. No problem, run this again. Okay, perfect. Run this to the bottom, and you can see it increasing like that. Okay, let's us continue. We might want to know what are the number of times that we were correct, what are the number of times that we were wrong, and we can just use something. We can just, like, when you check on combined here, when you check on combined here, you can see the number of times that we are wrong, right? But we don't know on which specific team. So what we can do to make it a little bit better, we can do a couple of mergings here. Let me just create a little bit more space here. Let's merge something here. We're going to take this combined, and then we're going to make it merge it, change it into combined, but now merged with something. What do we want to merge it with? We want to merge it with the matches rolling, and we want to add the date, and we want to see the team, we want to see the opponent, and we want the results. Sorry, I've not put this into brackets, into quotation marks, parentheses. Okay, then we want to merge left index being true and right index being true. So left index is true and the right index is also true. Okay, so when we check on combined now, now we can see of which teams we were wrong, right, etc, etc, etc. I think it looks good, and that's how we create a machine learning algorithm, and using rolling averages to try and make the algorithm a little bit better. Okay, finally let's try something here. Let's try and combine the home and away predictions, because finally we look at how our algorithm did in both sides, home and away. We combine the two to see and resolve any issues that we have. Things like, you can see Wolverhampton Wanderers here, but on the other side it is called Wolves, and see, you can resolve those. Let's do that real quick. So we create a dictionary and use the pandas map function with that dictionary. So we create a class that inherits from this dictionary. Let me show you what I mean by saying this. So let's just create a class called missing dict. That is a good name, I guess. Then on this it takes dict, and inside this it will inside this, let's just define this missing real quick. This class will be used to help us in something. Let me just finish up and you'll understand what I mean. Lambda self comma key. I think perfect. Okay, now let's create the dictionary I was talking about. Let's say map values. And then this dictionary itself will have all the teams. Let me just copy paste them. All the teams with issues like Wolverhampton Wanderers, Brighton and Hove, Manchester United, Newcastle, etc. Let me just copy paste that real quick. Okay, these are the only conflicting teams. So we just use this. Perfect. Okay, then something else we need to write here is mapping equals to now this missing dict, and then inside it will use this dictionary map values. Perfect. Run this. Okay, there's a problem somewhere. What have I not written? Oh, there's a comma that's missing here. Okay, so what does this mean? So when I do like mapping of a team like Arsenal, sorry, it's not callable. It is supposed to, let me just remove, sorry, it's supposed to be this, sorry, Arsenal. Okay, you can see Arsenal is Arsenal, but when you write something like Wolverhampton Wanderers, is that correct? Hampton Wanderers. You can see Wolverhampton Wanderers returns Wolves, and that's what we want. If we just use the Nini itself, this mapping itself, map value, this dictionary, Arsenal would have brought like a null value. Something like Arsenal would have brought a null value if we check on that. So let's just get rid of this, and now let's create a new. Let's just create a new column with the team names combined. Just create space here, then create this column, new column on this combined. Let's call it new team name, or new team. Let's call it new team. This will be equal to combined dot map into bracket mapping, and this will be the mapping of that, what we have just done right now. And when you check let's do this, we check combined now, you can see the names are, wait a minute, wait, Wait, why is it? Oh, I'm getting kind of tired now. I'm getting kind of really tired. Okay, no problem. It will use the team. It should be inside here. Okay. Sorry. Boom. Boom. Yeah. New team. So the team is the name, specific name. I think that's good. So what we want to do next is just merge this data frame to itself, so that we can see if the predictions match up. So let's just say merged. Create a new variable called merged, which will take the combined dot merge, and this combined will be merged to itself. So it will be merged to combine. What am I doing? Combined, and then the left on data new team. Date, comma, new underscore team. Okay, and then the right will be on the date and the opponent. Okay, then right on this date opponent. Okay, run this. Maybe there's an error. Okay, I think there's an error. Let me just check the script. Okay, the problem is here. There's no comma here. Okay, when you look at merged now, let's just check on the head, and now you can see we check for our team in the opponent and the first Arsenal, Burnley, and then let me just add maybe another 10 here. You can see Arsenal, just right, let me just put it like that. You can see Arsenal, Burnley, sorry, I want to see Burnley, Arsenal, and Arsenal, Burnley. So I think I'll go 50. Will I find everything here? Sorry, I'll go 50 on the header. Okay. Oh, Aston Villa. Let's go Aston Villa. You can see Aston Villa, Arsenal here. Okay. And you can see Arsenal, Aston Villa. Look for Arsenal, Aston Villa. We want to check on the predicted Y. Let's check on the predicted X. Let's just see the predicted X itself. Arsenal, Aston Villa. Arsenal, Aston Villa. You can see here, this is 1-0, and Aston Villa, Arsenal 0-0. You can see they predict a loss, and it happens, or predicts you can see there is a difference. So what we want to do now is we want to check on the number of times where the prediction was right, and the prediction, they said the home team will win and the away team will lose. See the percentage where we were right on that specific thing. Okay, we see where the prediction, where our model predicted that team A will win and team B will lose, and see how many times we were correct on that specific scenario. So it says Arsenal will win and Aston Villa will lose, and that's what actually happened. Let's do that real quick. So what we're going to do here is check on merged, and this merged, now we want to check where the merged We want to check where they merged, where the prediction of x. So prediction, sorry for that. I'm getting tired, my people. I'm doing this in one sitting, and it's getting a toll on me, but we move on regardless. We want to check where the prediction of y. Remove this. Where the prediction of x, where they said the prediction of x was equal to 1, and merged prediction of y was equal to 0. Then what we want to do is take the actuals of x and then do value count. Take the actuals, okay, actual. We take now the actual x, and we do now value count. Dot values count, value counts. Let's go counts. I think there's a mistake. I'm not sure I've written this well. This bracket here represents this other bracket on the end here. Okay, run this. There's a closing parenthesis that does not have a partner. Let me just check that. Okay. Probably I think this should be closed. And just for safe measure, let's put this inside a bracket. Just for safe measure, put this inside a bracket. Boom. Run that. Okay, there's a problem also. I've put it the bracket too far. It should be inside this. Run this. Okay, there's a parenthesis. Just a second. Okay, look at this mistake. Remove this. I guess I'm so tired. No problem. Okay, and these are the predictions, how they were. And now we can see that by just dividing the number of times this was right, by dividing 84 divided by 84, 84 plus 58 should be in a bracket. Run this. You can see we were about 59-60% of the time we were correct while trying to predict this. This is just something that you can just check to see how your model was doing, but yeah, and that's how you do that. You can just go through this. We can see how we first of all imported this request, took the data, converted it into the tables that we had, created the shooting data. The shooting data, combined the shooting data with the data of the matches, and then remember this algorithm, this specific this specific code was to extract the data. It took a little bit of time, did everything here, everything is perfect, until we got to a point where you have all the data that we had, used random forest classifiers, used accuracy, but realized accuracy was not the best form of checking for accuracy. We used precision, so we had a 51%, decided to use rolling averages, and these rolling averages increased it from 50 to 60%, about 60 to 60%, and we could also check on our algorithm to change a couple of things to see when we were right, when we were wrong, and when the prediction said that something that will happen on both sides that was correct, and what was the percentage of this. And that's how to create these algorithms. If you have any questions, just jump on the comment section. I'll see how I can solve them to the best of my abilities. And if you have reached the end of this video, you're a real rock star. Thank you very much. Enjoy yourself. See you in the next one.